is that slope. How you're moving from one term to the next. So let's get going here. 198 the next 198. Oh, okay. I just thought you were flipping through there, bud. Okay, so on page 198, I've got two tables. Now on these two tables here, that left side, that's again what we call as our input, our domain. On that right column, again, that's our output, our range. And I want us to identify on that right column, that first table here, how do you go from 2 to 6 to 10 to 14? You all should be able to identify this very quickly, how you're moving on that. How are we going by 2 to 6 to 10 to 14?
Plus 4.
Yeah, and make sure you can do it from one term to the next consistently. I did hear a times 3. That works for the first one, but does it work for the rest of those? No. So you got to make sure you keep doing it consistently from one term to the next. And then you guys said, yes, it's a plus 4, right? Now, what we say here, and let's put that plus 4 off to the side like we've done before, that plus 4 to identify that pattern. Yeah, Krista.
Yes, like, so could you already tell like how you got from one number? Because like, look at the very top of those numbers where it says plus 4.
So
like,
that's
if you
what.
just look at that, could you?
That's what I was just about to tell you.
Oh.
Yeah, no. So that plus 4, what we want to go back and do is connect it back to that plus 4, as we're trying to get back into, is it's the same thing as, in this case, that common difference of that D right there, which is that force you identified. Now, as we're going to see here in just a few minutes, we're going to take off that top row there where it says 2 plus 4. That's not going to be there, but we have to identify it like we did way back when. Now, on the next table, all right, how are we going again from -2 to 2 to 6 to 10? How are you going from one to the next? Adding 4 again, says Max. Now, this is the one that tends to trick up people right here from -2 to 2. Now, 2 to 6 to 10, that's pretty straightforward. 2 to 6 is a plus 4. 6 to 10 is a plus 4. And if you keep getting that same plus 4, go back and make sure a plus 4 works from -2 to 2. Well, you got a calculator in front of you. What is -2 plus 4? It is a 2. Sometimes the first one is not obvious. Go down another row and see if the next row makes it a little bit more obvious for you. 2 to 6 is obvious. Now, we get a plus 4 there. And as Krista pointed out on the last one, and the same thing is true here. This 4 is also coming from this y equals ax plus b. I keep trying to harp into you. What does that a represent? A is called our what? Slope. And our slope here is 4. It is one and the same. So that slope, that common difference you said in that last one, they are the same thing, guys. It just depends on how we're talking about it, what different type of context there, okay? So try to piece that back into you. So what we've identified there is a plus 4, plus 4, plus 4, okay? Now, yes? Give us a few minutes here. Now, on the next one, down below, okay? This person here, they've done it incorrectly. How do you go from 22 to 17, 17 to 12, 12 to 7? I'm sorry? Minus 5. Subtract by minus 5, same thing there. Right. Says Ryan. But what did they write off to the side there?
Minus 17. Oh, snap.
They did a plus 5. So when you read these going down like that, you should be reading it as 22 to 17. So when they went to subtract it, they did it incorrectly. What they should have been doing is, let's scratch that out. How should they have said this out?
Adding 17 plus.
You did it correctly in your head there, Ryan.
Switch to 22
and 17. Okay. So 22 to 17, you guys know you're going down. And in order to go down like that, you're subtracting. So what this error was, is they had set it up incorrectly. They flip-flopped around to 17 and 22. So what I was trying to get to. And when you go to your calculator, 17 minus 22 is a correct way of saying -5. And this is what that student had done on all of these. 17 to 12 is not correct. They're saying a 5. How do you go from 17 to 12? It should be a -5. So this person had the right idea, but flip-flopped around all those subtractions. So in order to calculate that -5, that Ryan said that is correct, you're always taking the previous one minus the first one. This is again what you guys had done all about 2 months ago on when we did these arithmetic sequences. Okay, when you guys looked at those patterns, we went through and tried to figure out how did you move from one term to the next. The only difference is I didn't give it to you in a table. I just wrote it out. They just wrote it out for you guys like this as a sequence. It's the same thing. This was our first term. This is our second term. That's our third term. It's the same way, just written as a table form. Okay. So 17 minus 22, 12 minus 17, 7 minus 12. You guys did a ton of that on Mathia. You guys did a ton of that with us. You guys know how to do that. Okay. Give us 1 second there, guys. Okay. All right. So then with that, that's what we want to do on this next part. Okay. Is keep that in mind. What we fixed right here, what we saw up there is trying to figure out how you guys are you changing on these tables. Are you seeing that same number continuing from here? Think back then to a couple months ago where we identified, are you adding 4, are you adding 4, are you adding 4? Are you subtracting 3, subtracting 3? Are we seeing that same pattern happen? All right, let's look at that next page then, because on the next page we do have a few more tables. And let's look at that first table here. Okay, and on this first table, what we have is our points. We have 5, 12, 6, 15, 7, 21, 8, 30. Okay, we need to see consistency happening. Now, what do I mean consistency happening? I need to see consistency happening on both kind of left and the right here. Are you going consistently on both sides? So what I mean by that, from 5 to 6 to 6 to 7 to 7 to 8, are you increasing by that same amount?
No.
5 to 6, yeah. So plus 1, 1, and plus 1. So far, so good. Now check the right hand side. You gotta check both sides. 12 to 15.
3.
Okay. 15 to 21.
6.
And as soon as we start to see a little bit of inconsistency there, what does that tell us? Way back when, did that tell us we were arithmetic? Yes or no? But did that tell us we're looking only at arithmetics now? But did that tell us that we're arithmetic? No. Because what do we need to see to be considered arithmetic?
The same number.
The same number every single time. Plus 3, plus 3, plus 3, plus 3. And you guys quickly told me we didn't have plus 3 there, did we? So here, our question's not asking are we arithmetic. Our question's asking us are we linear. That is like one and the same. Linear and arithmetic are going together. So would you say this table is considered to be linear? No. So what we're going to say then here is, we're going to say not linear, because it is changing by a different amount. And I'll pause and get out of your way for you. But you guys did well with this, again, way back when, and we sometimes saw geometric, and as Kristen pointed out, sometimes we saw neither geometric nor arithmetic. And really what we want to focus in on here now for just a crap ton of time into January to February, we want to see that arithmetic. We want to see it to be linear. We want to see a plus 3, 3, 3, 3, 3, 3, a plus 6, 6, 6, 6, 6 happen, and so on and so on. If we're not seeing that, we're going to say it's not linear because we're not seeing that same consistency happen. Okay, let's look at letter B. Now on letter B, there's a bit of a small twist on this one. Because on letter B, I see we start off with from -2 to -1. Then we skip, but then I see from 7 to 8. So from -2 to -1, how much does that change to by? -2 to -1.
Well, 1.
That increases by 1. But then we have this large gap, don't we? All right, how do you change from 7 to 8 then? Now, I've got some consistency there, don't I? Okay. If I get that large gap, I'll do that in a second. Now let's go look at 12 to 8. How do you change from 12 to 8? What? -4, thank you. And then we're right here. You're at -24, then you're at -28.
-4.
You're at -4 again. Okay? So on that, we did another, again, -4. Now I had that large gap in there from, what is it, -1 to 7. Now, in that case, we still have, though, that consistency off there, don't we? 1 and -4, 1 and -4. So we are still good to go of considering this to be a what? A linear function. Okay? So on this one, we're going to say, yes, it's linear. Yes, whoops, I can't spell. Yes, linear. Because of the same -4. Give you a second to pause there.
But isn't there like a better one? Isn't there like a better linear graph? Is there like a better linear graph on here? Or is
There could be some more. Yeah. Now, let's go down to letter C, and let's do the same thing now. Now, letter C, I want you to do that same thing here. Look at letter C. Go look at those X's. First thing on those X's, are you going from one to the next by the same amount? And then go look at the Y's. Are you changing from one Y to the next by the same amount? So go look at letter C. Are we doing that by the same amount? So go look at the X's.
Wait a second.
So are the X's there in letter C, are we changing by the same amount? Yes or no? we see on letter C, the x's are going by 10, 11, 12, 13. They are going by ones. Now, we gotta check the y's. And I'm looking for that same consistency. So, plus 1, plus 1, plus 1, yep. And plus 3 I heard, 4 to 9 is a plus 5, 9 to 16 is a plus. And we saw this, again, way back when, where we were adding, but we were adding by the odds. We were not increasing by the same amount, but we were increasing by the odds. And we tagged that one way back when as not arithmetic, not geometric, but as a neither. So do we say this is linear? No. Not linear. Not linear. Because it is changing. It is changing again by a different amount.
So if
Okay.
one is the same and one's different, it's not, but if one is the same and one is the same, it is.
We want to see that same thing over and over. We want to see that on the right-hand side, that minus 4, minus 4, minus 4, minus 4, plus 5, plus 5, plus 5. Just like we saw a couple months ago there, Jayla, when we said it was arithmetic. Okay, let's take that last table there. Go check those x's real quick. Okay? Are those x's, again, being consistent? Are those y's going to be consistent? What are those x's doing? Are they increasing by the same amount? Or I should say changing. Okay? So, Reed said I got a constant happening in here. For the x's, I see the x's increasing, plus 1. That's fine. But here, this is changing by how much? Nothing, which we say is 0. So here's the
But
yeah.
how
Here,
is linear if it's different?
so here's the odd one here. Okay. We had two other options where we were talking about lines. We had lines that were increasing. We had lines that are decreasing. And then we had two other things that happen with lines. Could be constant. And then we also had a line, if you remember when we talked about
It's going close to the line. Going close to going down.
vertical line test we did, okay, where we did the vertical line test, but it was just a vertical line, it wasn't working, okay? And on this one, I'm going to do a mini sketch off to the side. Let's see about that. Think about what does 1, 3 look like. Where's 1, 3 located? 1, 3 is right here. Where's 2, 3 located? 2, 3. Where's 3, 3? 3, 3. Where's 4, 3? 4, 3, right? So what type of line are we creating there? Correct. We're creating a horizontal line. What do we say about those horizontal lines? They are constant. Good. So on that one more time, do we have ourselves a line, a linear function? Yes, we do. Yes, just like we did up here, I should say yes, linear. Less
So
linear.
what is 0?
1 second. Because of the same change of 0. One more time, Jayla.
Is it because it's 0?
I've seen that plus 0 on that right-hand side continue to happen. That is correct. So you see that left side, plus 1, plus 1, plus 1. That right side, plus 0, plus 0, plus 0. Because that's that consistency that keeps happening. That is what we want. I don't care if this is plus 0. As long as I see that same number keep happening, we say it's linear. Okay? Now, we did that hard part there of identifying what we say is those numbers, determine if it's a function or not, linear function or not. Last thing we're going to do now is come back around and answer out the last part of the question. The last part of the question says, if it is a linear function, it wants me to write it as a linear function. So let's go back to what we were working on Friday. What we've been trying to do with you guys since about beginning a couple weeks ago. Back to linear regression. What is the equation for, again, slope-intercept form? Y equals
Ax plus b.
plus b. So that's what we want to now do. For going back up to ones that said yes on, which was b and d. Y equals ax plus b. Now, earlier, a few minutes ago, beginning of these notes, we reminded ourselves that the slope was the a. We just found the slope. The slope was what we were changing by. What did we say we were changing by on letter B? Negative 4. So let's put that on in there. Negative 4x. Okay, the one thing that we don't have though is the y-intercept. We gotta go find that. Now, one thing we keep trying to talk to you guys about is the y-intercept occurs when the line crosses the y-axis. I don't have a graph though. So here's what we're going to start working on with you guys with. Here's where the y-intercept is happening. Let's put it into our table. The y-intercept is happening right here when x is at 0. So the y-intercept is happening when it is 0 comma something. When it's 0 comma something, that's where it's hitting the y-axis at. So let's go through and let's look at our table. We're changing by negative 4. We're right here at negative 1. We're going minusing 4. We're at negative 1 here. We got 8. If I want to go to 0 and we're going down by 4, where is that going to put me at? 4. Because to go from point to point to point to point, we're decreasing by 4. So if I'm here at negative 1/8 that they gave us, one of you identified, hey, we were subtracting 4. So to go from negative 1 to 0, I got to subtract 4. Andrew said, hey, what's 8 minus 4? 8 minus 4 is 4. And what we've identified is a very special point we're going to be working with. That's, again, our y-intercept. We can see it when it crosses the graph, the y-axis, I mean. But I want us to start identifying it in our table. And when it's in our table, it's going to happen here when x is 0. So I created it, like right here I did with you, by saying 0 right here, find your pattern. Boom, here's our pattern. 8 minus 4 is 4. It's our first time to do it. I don't expect you to be like, what the heck is he doing? Cool, but give me some time. Now, what's the other one we just did? Letter D was linear. Okay, let's look at letter D. Y equals ax plus b, said Matt. That was our equation. Okay, what did we just say our slope was on that one? We were changing by what? 0. I need to know what the y-intercept is. Now, where's 0 located for the x? Right here. We're going to label that out. Label that out. The more times you do it, the better. You're going to stick with it. Now, let's make the pattern. Right here, 1, 2, 3, 4 gave me 3, 3, 3, 3, 3. If I put in a 0 now, what do you think is going to be here? How are we changing there, Andrew?
So,
It's going to be 3. Okay? Because how are you changing from one point to the next? You're adding how much? What should we say? We're adding 0. So where's that going to give us to? 0, comma 3. That's going to make the y-intercept. That's going to give me that constant that's still going to happen. Now, yeah, we've seen this before. Do we say 0x? What's 0 times anything?
0.
0. It drops out, doesn't it?
Yeah, but then isn't there always like
No. Because if you say x, what's in front of that x? Hold on, people. A 1. If you say 1x, if you say x, there's a 1 in front of that x. We didn't say there was a 1 in front of the x. We just said there was a 0 in front of there. So we're dropping out that 0x by just literally dropping it out. We're saying it is just y equals 3. If I go to my graphing calculator and I graph out those two, a second ago, you guys graphed out those points and you told me it was constant. That gets me a constant line. But if you tell me y equals x plus 3, you do not get a constant line because that's a 1 in front. If it's a 0, I should be getting a constant. That's what that does. So 0x drops out completely, and these things are saying the exact same thing here. Y equals 0x plus 3 is the same thing as y equals 3, right there. Okay. Now that's the first time we've done it. I don't expect you to have that mastered, so let's do a few more practices with that. Okay. So let's do a little bit more practice with that. Let me get out the assignment here. Let's do a couple more things with that. Okay. Keenal's got that, I think, and I will bring that up as she does that. Keep those. Let's do this. Let's take a look here. Let's take a look at number 3. Right there, guys. Number 3 in the middle. This one's away. Number 3. Let's do a few more practices. Okay, I want to do the same question we just talked about. Is that table considered to be linear?
Yeah.
Okay, well, let's go. Identify yes or no y. All right, I heard a yes, but let's now say y. Okay, so first thing is I'm looking at those x's, making sure I see consistency there, but then I let's go get the y's. So first thing on the x's, I'm seeing a +1, Krista.
It's kind of changed like the amount that you're going by.
What we just talked about. It's the same thing as the slope. Correct.
You -2?
So yep. So let's go check all that. And I'm seeing a +1 definitely happening there, right? I want to see consistency there, and I want to see consistency here. Again, this is everything we've done. We did all that. 7, 5, 3, 1. That's a -2, right? And if you don't see that -2, then you're done. But we do see a -2 and a +1 so far. So good. So what does that mean? We are linear. So unfortunately, that means we continue on with this problem. Let's put the phone away. All right. Now, that rate of change, that's the same thing as the slope. That's the same thing as the common difference. So we're good. We've identified it. It's -2. We're done there.
How the negative?
So just
That's what you're changing by.
so it says rate of change is always y. So it's the rate of change.
I'm going to throw a curve in there later on. Okay. But I'm going to go right now, Andrew. Yes. Okay. Now, what does that -2 also tell us we're doing, guys? Yeah, we're decreasing, isn't it? Nothing crazy. Now I'm going to add on one other question to this. Let's write our equation here, just like we did the last minute ago. What is our equation that goes with linears? Y equals what?
Y equals 1
AX.
plus
bx.
negative 2b.
Okay.
B. And negative 2.
I know.
Shush.
Hey, I'll take what I can get today. Y equals AX plus B. slope, and then the y-intercept. We found the slope. When you guys look at that table and you determine if it's linear or not, once you say it's linear, you found the slope. And the slope is that rate of change. It's that common difference. So we got y equals negative 2x. We're halfway there. The only thing you're missing is that y-intercept. The y-intercept is that nice point where it's crossing the y-axis at. Do I have a graph though? No. So I'm looking at my table. It's that special point that I did on the notes with you, where I'm looking at that special point in my table where I see 0 comma something. Do I see in my table a 0 comma something? Look at your table.
0,5.
That's the point I'm looking for. If I see that point 0 comma something, it is saying, look at me, I am super special. 0 comma 5 right there, highlight it, label it. When you see that point, you want to identify it and realize that is a very important point for us.
That's the y-intercept.
That is always the y-intercept. When you see 0 comma whatever, 0 comma 5 in this instance, if we go and graph this out in just a second, I absolutely promise you that that's going to be going through the y-intercept, the y-axis at 5. So even though we don't have a graph there, that is telling you it's going through the y-axis at 5. So I'll give you 1 second. So this graph is going to be doing two things for us. I think Jayla said a second ago, it's going to be decreasing because the rate of change was negative, and it's going to be going through the y-intercept where? At 5. Because the y-intercept is where it crosses the y-axis. So if I go graph this now for us, does it do those two things like I promised you it should do? And if it doesn't, well, that's going to be pretty embarrassing. Okay, it's decreasing because the rate of change, the slope was negative. And where is the y-intercept at? Right there at 5. Okay? Those are the two pieces we always need. Jayla, what you got?
What?
You had a hand up a second,
Oh,
but I
yeah.
said I'd come back to you.
What if it doesn't have a 0? You just
I
go
will.
circle like that?
Yep. We'll have to find it out, and I'll talk to you about that here in a minute. Okay. We did that one on. We did one on our notes. We'll do another one. Okay. Let's go to the next one. Letter B. Do I see consistency?
Nope.
Okay. I see 10, 11, 12, 13.
That's on the X on the Y.
Oh, okay. So let's make sure we're looking everywhere. Yep, that looked good on the X's.
Plus 3 plus 4.
Yeah. And make sure you see it everywhere. I see 3, 3, but then check the whole thing because it screws up at the very end, doesn't it? And as soon as you see it screws up at some place, you don't see a consistency, what are we going to select? Nonlinear function. And then these two things are not going to happen. You cannot determine the rate of change. You cannot tell me if it's going up or down because it's not a linear function. It's got none of those things going for us. How about the last one?
Nope. Not on the Wi-Fi though.
Okay, let's go and look at that. Plus 1 again, and we're going to fix this one so it can do something for us, Andrew. So what are we doing? We're going down. Let's make this a -9. Okay? We're going to fix it so we can do this one, okay? Because I went 2 yeses. So Andrew said, and I heard some other people say, this was not a linear function. We're going to change it so we can do that. And that's going to get to Jayla's question too. So what are we doing from -3 to -5? Is that going up or going down?
Going down.
It's going down. -3 to -5 is going down by 2. Going down by 2. And by changing that to a -9, that still goes down by 2 now, right? Okay. So I fixed that for us so we can get ourselves what? A linear function, don't we? And the rate of change is? And what are we doing?
Decreasing.
Okay, let's write our equation again. Can't stress that to you enough. Y equals ax plus b. The rate of change we found. That's the slope. And Jayla said, hey, what if they don't give me the 0 in that table? you can find it pretty easily. Co-create it. Where's that 0 gonna land, Jayla? Where is it gonna be in that table? Right before the 1, right? So Jayla, go put that 0 in there. Now look at your pattern that we've created, Jayla. Finish the pattern here. So walk yourself back upwards now. -9, -7, -5, -3. What's that gonna have to be right up there?
Wait, what?
-1.
What did you do?
I was going backwards.
Oh.
Going backwards by how much? 2. So I was adding 2, right? 9, 7, 5, 3, and that's going to be a -1. So what I've done here is I went to go find the y-intercept by just following the pattern, right? And what I've created was the y-intercept, which is at 0, -1. So again, Jill asked a good question. She said, hey, what if the y-intercept's not in that table? Go make it, all right? Go put that 0 in there. Follow your pattern. You guys are good at patterns. Go make the pattern. Go put that 0 wherever it's located, and then finish off that pattern back to that just like we did. Okay, cool. We're right there then. All right? All right, let's finish strong here. Let's take number 4A. Let's go graph out that line. Give me 2 more problems and we'll call it a day. Okay? So, on letter A. Okay, number 4 there, letter A. Let's go graph that line, everybody. What do we graph first? This is essentially what we've just been talking about, a little bit different format.
The y-intercept.
Y-intercept, thank you, Krista. Y-intercept is 4. Yep, 0, 4. It's where we're crossing the y-axis at.
And the x-intercept is 2, 0.
Oh, I got you. I just wasn't following you. So the slope is -2/1. That's where we've been doing that for the last 3 or 4 weeks, reviewing that stuff. Play that slope game. -2 and 1. So that means down 2. And that's a +1. So right 1. Down 2, 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 right 1. Take your ID and make that nice line. And Krista, you said a second ago the x-intercept was another special point. And what was that location, Krista?
Oh, I said 2, 0.
Thank you. We had the y-intercept always. And the other special point that we've identified, we talked about, we'll keep talking about it, is what we call the x-intercept. It's going to come rearing its head when we come back here for Thanksgiving. Okay, let's do the other one there real quick, letter B. 3/2 x minus 2. Go graph me that y-intercept. Again, it should be a quick knee-jerk reaction to graph a line. Shouldn't have to think about it at all. Y-intercept is at -2. 0, -2. We just got done talking about that off of our table. 0, -2. Slope is 3/2. We've done this type of work in so many different ways, from the linear regression of AX plus B from your calculators, from Decimals calculator to the 84 calculators. Now back to here today, our table of values, okay? So now play that slope game of up 3, right 2. 1, 2, 3, right 2. 1, 2, 3, right 2. I can't go anymore. I like to reverse that. You guys know that. 1, 2, 3, left 2. And whenever you take your ID, all those points should fall on that line. There we go. Okay. So we're going to keep working with lines and tables and slopes and linear functions. Tomorrow with Matthew. Then we come back to Thanksgiving break. Okay. All right.